In this problem, we see that Justine is a wedding coordinator and she's selecting the menu options for the reception. So first, she's going to give them a choice of salad or soup for the first course, for the appetizer. Then she's going to let them pick chicken, steak, or vegetarian for their main course. Finally, she's going to allow them to choose between the bride's vanilla cake or the groom's chocolate cake. This problem asks us to create a tree diagram to show every possible scenario for how a guest could select their meal. So take this one step at a time. We have first salad or soup. So since my options here are salad or soup, I'm going to write salad as option 1. I'm going to write soup as option 2. From there, we look at the next one. There are 3 choices: chicken, steak, or vegetarian. So if you have salad, you can have chicken, steak, or vegetarian. If you have soup, you can also have chicken, steak, or vegetarian. So branching off, chicken, steak, vegetarian. Branching off from soup, chicken, steak, vegetarian. So no matter which appetizer you get for the first course, you have the option of chicken, steak, or vegetarian for your second course, your main course. For the last one, we have vanilla cake or chocolate cake as the bride's or the groom's. So it doesn't matter what you chose before. Salad with chicken can choose vanilla. Salad with chicken can also choose chocolate. So branching off of these, vanilla, chocolate, vanilla, chocolate, vanilla, chocolate, vanilla, chocolate, vanilla, chocolate, vanilla. Getting a little overexcited there. Chocolate. So now we have every option available to us. We have to count how many of these options are available. So starting off, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total outcomes. Because there are 12 total outcomes down here at this problem, we're going to write the number 12. How can we use the counting principle to determine the number of outcomes? Well, let's back up just a little bit. How many options did we have in red here? We had 2 options, salad or soup. 2 options. If we look at the main course, how many options do we have? 3 options. I'm going to put the number 3 down. And then for the last one, how many options do we have? We had an additional 2 options. By the counting principle, we're going to take all of our options and we're going to multiply them together. So we have 2 times 3 times 2. 2 times 3 is 6, times 2 gives us 12, which is the exact same thing that we got earlier. So let's use that same sort of principle for the next problem. I'm looking at question number 2, where it says there are 4 different trim levels. Now, I don't need to specify that it's CX versus DX versus EX versus SI. I just need to know that there's 4 of them. So starting with our counting principle, I write down 4. I know that there are 5 different colors that this can come in. Whether it's night black, pearl white, evening blue, sandy red, forest green, there are 5 total. So I'm going to put down the number 5. There are 3 different interior options. That's 3 I'm pulling from here. Gray cloth, tan cloth, black leather. So I'm going to write down 3. And according to the fundamental counting principle, or just the counting principle, we're going to take all of these, we're going to multiply them together. 4 times 5 is 20 times 3 gives us 60 different versions of this model. So with the 4, the 5, and the 3, we get 60 different options. If we look at question number 3, now we're looking at a phone number. So if I'm looking at ABC-DEFG, how many different possible phone numbers are there? Well, let's look at what it tells us. This tells us that A is restricted to a number between 1 and 9. So typically you can highlight this, circle this, whatever, but we need to know that this is just for A, not for everything. How many numbers are there between 1 and 9? Well, there's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 total numbers. Our next hint it tells us is that B and C are restricted to any number between 2 and 9. So A was between 1 and 9. B and C are between 2 and 9. So 2, 3, 4, 5, 6, 7, 8, and 9. That means that B has 8 available. C also has 8 different options available. The last thing that it tells us is that D, E, F, and G have no restriction. What that means is that it can be any digit. In total, there are 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So for D, we put 10. E, we put 10. F, we put 10. And G, we put 10. By the counting principle, I'm going to take all of these and I'm going to multiply them together. When I do this, I'm going to get 5,760,000. That's 5, 7, 6, 0, 0, 0, 0. That's a lot of different phone numbers. Now let's just review where we got all of these from. The 9 came from A. The 2 8s came from B and C. The 4 10s came from D, E, F, and G. So make sure that all of your variables are represented when you're doing this multiplication. Our last one is talking about another phone number, but this time instead of just having A through G, they threw in this X, Y, Z. So X, Y, and Z, this front bit here only has 4 possible combinations. Now, to us, it doesn't matter what those 4 possible area codes are. We just care that it's 4. So when I write this down, I have my X, Y, Z gives me 4 possible combinations. Next, let's look at specifically A. A is restricted between 2 and 8. So 2, 3, 4, 5, 6, 7, 8. There are 7 numbers between 2 and 8. So A gives us the number 7. Digits B and C can be any number, but they cannot repeat. Because they cannot repeat, if I choose 1 for B, C does not have the option for 1 anymore. If I choose 7 for B, C does not have the option to be 7. So if it's any number, think back to question number 3 where it had no restrictions. There were 10 things that could be available. So for B, you have 10 options, 0 through 9. For C, you have 10 options minus the one that B took. So if it's B is number 9, then we have 0 through 8. If 0 is B, then we have 1 through 9. So instead of having 10 options, for C, we're going to have 9 options. And D, E, F, G have no restrictions, which is what we see right here. Because they have no restrictions, that's when we pull out that 10. So D is 10. E is 10. F is 10. G is 10. And based on the counting principle, we take all of these numbers and we're going to multiply them together. When we multiply these together, we get 25,200, or 25, 200, 0, 0, 0. So that's even more combinations than we saw in question 3. This has been the front of your counting principle worksheet.